The title of these notes is Adding and Subtracting Fractions. Your outcome is that I can add and subtract fractions with variables. So we're going to start off by talking about adding fractions, and we're going to go really basic here. Let's suppose we wanted to add 2/3 and 4/7. How do you add fractions? In order to add fractions, their denominators have to be the same. So what you want to do is you want to multiply by what I call a fancy form of 1 that'll force the denominators to be the same. So my two denominators are 3 and 7. I want to think of the least common multiple between 3 and 7, which is 21. So 21 is going to be my least common denominator. So taking a look at 2/3, if I want the denominator to be 21, I need to multiply it by 7. I'm allowed to do that if I also multiply the numerator by 7, because 7 over 7 is equivalent to the number 1, and when you multiply a number by 1, you're not changing the number. So 7 over 7 is our fancy form of 1. Likewise, to the 4/7, the fancy form of 1 we're going to use, think of your denominator first. I need to multiply 7 by 3. So I'm going to multiply the numerator by the same thing. My fancy form of 1 is 3 over 3. So now we're going to do this multiplication. You multiply across. Do not say cross multiply. That is a banned word. Never, ever, ever say cross multiply. You are multiplying across. So you multiply the numerators and you multiply the denominators. You do the same thing to the other fraction. Multiply the numerators, multiply the denominators. So an equivalent expression is 14/21 plus 12/21. Now you can add the numerators together to get 26 all over 21. That is the sum of those two fractions. So to recap, we found the least common multiple, and then we multiplied each fraction. Then we multiplied each fraction by a fancy form of 1. To get the least common denominator. And then the last part is that we added the numerators. So this is all review. We know how to add fractions like that. Now we can do it with variables. So let's take a look at this first one. We have 3u over 4 plus 2u over 6u squared. So we want to first think about what is the least common multiple between 4 and 6u squared. Look at the numbers first. What is the least common multiple of 4 and 6? If you're not sure how to do this, what you can do is you can factor the numbers. And you'll see that both of them have a factor of 2 once. So you can just count that one once. So you use all the factors, the ones that are repeated, you only use once. And if you multiply those together, you'll actually get the least common multiple. So 2 times 2 times 3 is 12. Both 4 and 6 are divisible by 12. And then the least common multiple of u squared is just going to be u squared. So our least common denominator is going to be 12u squared. So what we have to do now is we have to ask ourselves, what do we need to multiply each fraction by to get 12u squared? So starting on the left, what do we need to multiply 4 by to get 12u squared? We have to multiply 4 by 3 to get 12, and we need to bring in u squared. And then because we can only multiply by a fancy form of 1, we'll do the same thing in the numerator. And then on the other fraction, what do we need to multiply 6u squared by to get 12u squared? We need to multiply that by 2. So then we go ahead and we do that multiplication. I'm going to erase all of this over here. So the left fraction becomes 9u to the third power, because 3 times 3 is 9, u squared times another u is u to the third power, all over 12u squared, plus 4u all over 12u squared. So now we can add our numerators. And then we have our fraction. This one I actually notice I can simplify. I see that every single term has a u in it. So I can actually factor out a u. And in the numerator, that leaves behind 9u squared plus 4, because factoring is like dividing. And then in the denominator, it leaves behind 12u. And right here, u divided by u is equal to 1. So we could write our final, most simplified answer is 9u squared plus 4 all over 12u. Okay, so now we have a second example. Take a look at that second fraction. Before I even do anything, I notice there's a GCF of 2. That's the first fraction. The second fraction, I can factor a 2 out of every single term. And I find that interesting because the other denominator already has a 2. So really, all I need is the other denominator to have the factor a minus 2. So now that's going to give me, now I have to distribute here. 6a squared minus 12a all over a minus 2 times 2 plus 6a all over 2 times a minus 2. Those denominators are the same because the order of multiplication does not matter. I'm not going to simplify them just yet because I have a feeling there's a GCF of 2 hanging out up here that I'm going to cancel out. So go ahead and adding those numerators, 6a squared, and then I have negative 12a plus 6a is negative 6a, all over a minus 2 times 2. I do see a GCF of 2 in the numerator. And so that does factor out. And while there is a GCF of 3a in the numerator, it doesn't exist in the denominator, so it's not worth factoring out. So that's how you add fractions. On the next page, I have 2 more examples for you. These are for you to try on your own, and there are answers here. So what you should do right now is you should press pause on the video, try each of these problems, and make sure you can get the answer in red. Then we're going to go on to the next page where we're going to discuss subtracting fractions, very similar. Okay, so if we have 3/4 and we want to subtract 1/6, exact same process. We're going to look for the least common denominator, the least common multiple of 4 and 6, which we already talked about is 12. So we're going to say, hey, what do we have to multiply 4 by to get 12? That would be 3. So multiply the first fraction by a fancy form of 1, 3 over 3. Then we go to the next fraction. Hey, what do we have to multiply 6 by to get 12? That would be 2. So we multiply that fraction by 2 over 2, which is a fancy form of 1. So we have 9/12 minus 2/12, which gives us 7/12. So now instead of adding the numerators, we're going to subtract them. Where most people get stuck here is what if there are 2 terms in that second numerator? So for example, what if this said 9/12 minus 2 plus x 12? You have to remember that you are subtracting the entire second numerator. So it becomes 9 minus 2. You can think of distributing that negative sign, minus x. So it becomes 7 minus x. One mistake people might make is they might say that it's 7 plus x, forgetting to distribute to that second term. So again, we're going to look at 2 examples together. All right, so first one we have 5y over 2y cubed minus 5 over 4xy. So we're looking for the least common multiple between 2y cubed and 4xy. Notice they both have a factor of 2, and they both have a factor of y. So if I write this out, just like we did with the numbers, the factors that are repeated, we only need to write once. This other 2, bring it down. Anything that's not repeated, you'll bring down. This y that's repeated, we only need it once. Bring down the other 2 y's that aren't repeated. And then bring down the x. So the least common multiple is going to be 4xy cubed. So that'll be our least common denominator. Convention says that we always go in alphabetical order. We're going to put the number first, and then we're going to go alphabetical order x and then y. So now that we have our least common denominator, we need to multiply by a fancy form of 1. What's missing from 4xy to get to 4xy cubed? 2 more y's. What's missing from 2y cubed? A factor of 2 and a factor of x. So that is going to give us, I'm going to write down here, the first fraction will be 10xy all over 4xy cubed minus 5y squared all over 4xy cubed. So now it's very similar to addition, except we are subtracting the numerator. So our final answer is 10xy minus 5y cubed all over 4xy cubed. Looking for GCF, 10, 5, and 4, there are no GCFs there. There's an x term here and here, but it's not over here, so that's not a GCF. However, all 3 terms do have at least one y factor. So let's factor that out. So that leaves us with 10x minus 5y all over, factor out a y from that term as well. Y divided by y is equal to 1. So the most simplified answer is 10x minus 5y all over 4xy squared. Let's do one more example of subtraction. Okay. I do not have any GCFs between 2r and 1 or 5. So the fancy form of 1 I'll use here is 5 over 5. And over here, 2r minus 1 over 2r minus 1. Remember to distribute. So I get 12r minus 6 all over 5 times 2r minus 1. I'm not going to distribute the denominators yet, just in case I see a GCF. And then 5 times 4r. And then I'm going to subtract. 12r minus 20r is negative 8r. Do I see a GCF? Well, in the numerator, I do see a GCF of 2. I could even say it's a negative 2, so that because I have 2 negatives. But that's not really helping me, because I don't have that GCF in the denominator as well. So I just did that to explore to see if there's anything that canceled out, and it looks like, hey, nothing's going to cancel out. So I'm going to go back to this version, and I'm going to go ahead now and distribute, since I'm sure that nothing will cancel out. And there's the simplified answer. So again, there's 2 more. You should try each of these. Make sure you know how to get the answers in red.